This is Mr. Anderson for Kellogg Community College with part 2 of our first section of our book talking about quadratic equations. Now, what's important about this is we're going to spend the entire time talking about how to complete the square. Completing the square is the idea that we're going to take a trinomial that isn't a perfect square and we're going to make it into a combination of x plus a number quantity squared or x minus a number quantity squared. So our goal is to get each of our problems to look like either x plus a quantity squared or x minus a quantity squared. So to complete the square for the general term x squared plus bx, we would add the b term divided by 2 and then you'd square that. For example, if you have 16, you are going to take 16, divide it by 2, and then square it, and that will give you the missing number here. So for example, 16 divided by 2 is 8, and 8 squared is 64. Now, two numbers to multiply to make 64 and add to make 16 is 8 and 8, or x plus 8 quantity squared. Because if I FOILed this out, it would give me this trinomial. A couple things to note. Do you note that the 8 is the square root of 64? Moreover, the plus symbol is there because of the second term, not because of the third term. And we'll see that more as we move to this problem. So 6 divided by 2 is 3. The square of 3 is 9. Now, you'll notice that we are looking for two numbers that multiply to make 9 and add to make negative 6. That combination is x minus 3, x minus 3, or x minus 3 quantity squared. You will notice that the 3 in this binomial is the square root of 9, but the subtraction is more because of the second term of the problem, not the third term. When we move to a problem that actually is not divisible by 2, as we note that 9 divided by 2 is in fact just 9 halves, not simplified into a fraction or a smaller fraction or decimal. To square that, you're then going to get 81 fourths. Now, it's harder to answer this question. What are two numbers that multiply to make 81 fourths and add to make negative 9? So we're going to use the patterns up above to try to find this binomial. This is going to be x minus because of the second term of the problem, 9 halves. And this is going to be quantity squared. And the reason for that is because 9 halves multiplies to make this in the L cable of FOIL, and also the middle two terms simplify to make the negative 9x in the middle. So this is going to be our finished problem here. Again, look for synergies here. 9 halves is the square root of 81 fourths, and the middle terms plus or minus determines your plus or minus here. Now things get even more complicated when we have a fraction that needs to be divided by 2. Here's 5 thirds. 5 thirds needs to be divided by 2. Now, doing this might be a little tricky, but if we remember skip, flip, multiply, we've got 5 thirds times 1 half. And 5 thirds times 1 half is 5 sixths. And if I'm going to square that to put that into this missing blank, that gives me 25 over 36. Because it's difficult to think, what are two numbers that multiply to make 25 36 and add to make negative 5 thirds, it's best to look at the pattern in the problem. So what is the square root of 25 36? Well, it's 5 sixths. So I've got x minus 5 sixths quantity squared. If I FOILed this out, this would give me, the L cable would give me this term here, a negative 5 sixths and a negative 5 sixths would make a negative 5 thirds, because that negative 5 sixths and negative 5 sixths makes a total of negative 10 sixths, which is simplifiable to negative 5 thirds. If you don't believe me here, please FOIL this out and you will see that this is the trinomial you get from this square of this binomial. So one last time, to find the missing third term of each of these problems, you would take the b, which is the coefficient of the second term, divide it by 2 and then square it. That gives you the third number in the list. Then take the square root of the third number to put it here, and then the plus or minus of the symbol to put it here. So that is how you complete the square. We're going to do a couple more problems actually with solving for x in mind. So we're going to complete the square in problem number 15 and 16 for this next part of the video here. Now, in problem number 15, you are trying to find a number that I could put into this space where the arrow is that would complete the square so I could solve for x. Now, I have to think to myself here, okay, x squared minus 4x. Now I'm going to put a space here because I'm trying to find that number that would go in here to complete the square. Please understand I still have my negative 23 on the other side, and anything I put here in this blank, I'm going to have to put in the blank over here on this side as well. Because you cannot just add a number to one side of the equation and not add it to the other. Okay, so what two numbers multiply to make negative 4? I'm sorry, I'm jumping ahead of myself here. We're going to take my b, which is that middle term here, divide it by 2, and then square it. So that's going to be negative 4 divided by 2 squared, or just 2 divided by 2. I kind of ignore the negative here because once you square it, it turns positive anyway. So 4 divided by 2 is going to be 2, and 2 squared is 4. So I have to add 4 to both sides. What this gives me is now two numbers that multiply to make 4 and add to make negative 4. Using my pattern from up above, this is going to be x minus 2 quantity squared is equal to negative 19. Now, what we can do is we can take the square root of both sides because now we have this square isolated. So now I have x minus 2 after I take the square root of this side, and this side is going to be plus or minus the square root of negative 19. Now, what we learned earlier is that the square root of a negative number is going to be I. So this becomes x minus 2 is equal to plus or minus 19 under the square root times I. Then we just move the 2 to the other side, so x is equal to 2 plus or minus the square root of 19i. Looking at problem 16, you'll notice that this is another unfactorable problem. I don't know of two numbers that multiply to make a negative 5 and add to make 6. Positive 5, sure, but not a negative 5, because that means I'd have to have a negative 1 and a positive 5, or a negative 5 and a positive 1. So what we're going to do is we're going to leave a space here by moving that 5 to the other side. Now, by moving that 5 to the other side, by adding 5 on both sides, I leave myself a space to complete the square. You always want a space to complete the square, and that way you can square the left-hand side and the right-hand side to solve for x. So I'm going to take my, just like I see over here, b divided by 2 squared. I'm going to go 6 divided by 2, which is 3, and square it to make 9. So 9 is going to be what I need to complete the square. This is 9, and this is 9. So this makes x plus 3 quantity squared, because 9 is the square root of 9 is 3, and the middle term tells me if it's positive or not. And this is equal to 14. Now what I get to do is take the square root of both sides. So I get x plus 3 after I take the square root of the left side, and on the right side I have plus or minus the square root of 14. Then I move the 3 to the other side, x is equal to negative 3 plus or minus the square root of 14. Please understand that these are two different answers. It's an answer of 3 plus square root of 14, which you can type in and get a decimal, or negative 3 minus square root of 14 and type in and get a decimal. These answers are actually where the equations hit the x-axis, and 17 and 18 are going to be just that. They're going to be completing the square and then finding the x-intercepts for them. Alright, so let's do a little screen draw here. Click on this. Okay, so we're going to find the x-intercepts. So this means we want to find out when this is going to hit the ground. Now, I have in previous problems here, instead of putting g of x there, I've actually set this equal to 0. Because in my case here, 0 is going to be hitting the ground. Now, it is weird to have the equal 0 on the left-hand side here, so I'll transfer it over to the right. But since I can't think of two numbers that multiply to make negative 2 and add to make 10, I am going to move that 2 to the other side using the power of addition. So I'm going to add 2 and add 2 to both sides. And I've also at the same time used my symmetric property to move the 0 to the right. So now I'm going to complete the square next to my 10x and add and fill in the blank right there and there to help myself out. So again, to complete the square, you take your b, your middle term, divide it by 2, and then square it. And that's give you the number to fill in the blanks. 10 divided by 2 is 5. 5 squared is 25. Now I can't add 25 to one side and not the other, so this is completing the square on both sides. So what I'm going to do is then take a look at what two numbers multiply to make 25 and add to make 10. That would be 5 and 5. Now to simplify this, I'm going to go x plus 5. Sorry, I wrote the 2 there. X plus 5 quantity squared is equal to 2 plus 25, or 27. Take the square root of both sides. X plus 5 is equal to plus or minus the square root of 27. Now, I'm going to move the 5 to the other side, so x is equal to negative 5 plus or minus. Now, before I write the square root of 27, I'm noticing that the square root of 27 can be broken into two parts. It can be broken into the square root of 9 times the square root of 3. Because 9 is rootable, this becomes the square root of, or it becomes 3 times the square root of 3. So negative 5 plus or minus the 3 times the square root of 3. Now, those are my two answers, but you'll notice that the instructions say find the x-intercepts. Well, this is going to hit the ground at negative 5 plus 3 square root of 3, comma 0. That's the first x-intercept because of the plus sign. The second x-intercept is going to be negative 5 minus 3 square roots of 3, comma 0. What might be nice is that you try these out on a calculator and see what the decimals are, after you type this in and this in, and then type this into your y equals to see where it is on your screen. Okay, we're going to keep doing the same thing here. We're going to do a little bit of completing the square, but you'll notice that this case, this square is going to be kind of weird because of the 5. Now, again, I'm going to start off with x squared plus 5x plus 2 equals 0. Because I want to see when it hits the ground. Now I've got to give myself just a little bit of space, and I'm going to do so by moving the 2 to the other side like this. Now I have to find these blanks. I find the blanks by taking my middle term, 5, dividing it by 2, and then squaring it. If I go 5 divided by 2 and square it, I get 25 fourths, because 5 divided by 2 is 5 halves, so I'm going to add 25 fourths to both sides. Now, what this gives me is on the left-hand side here, a binomial. Take the square root of 25 fourths and you get 5 over 2. And the middle term is positive, so that's as positive. So x plus 5 halves is going to be what I'm going to have on my left-hand side. Now, through the power of technology, since I don't really want to spend time reteaching fractions here, if you type in negative 2 plus 25 fourths, you can simplify this down to positive 17 fourths. Again, please use your technology, and if you need a refresher on fractions, there's plenty of videos to go over that. Now what we're going to do is take the square root of both sides, so now I have x plus 5 halves is equal to plus or minus the square root. Now, before I take the square root of this, note that I can break the square root into the top and bottom here. So if I take the square root of this part, whoops, sorry, pen's not working there. If I take the square root of this part and take the square root of this part, I can break this into the square root of 17, but the square root of 4 is perfect. Square root of 4 is 2, which is really great because I get out of rationalizing the denominator here. I move the negative 5 halves to the other side, so x is equal to negative 5 halves plus or minus the square root of 17 over 2. This is actually an answer, or two answers for your two x-intercepts. So your first x-intercept is going to be negative 5 halves plus square root of 17 over 2, comma 0. And your second is going to be 5 halves minus square root of 17 over 2, comma 0. Again, what's interesting is you could type in these into your calculators, see what the decimals are, and then verify by typing this into your y1, and then graphing it. You could then see, oh wow, that's exactly where it hits the ground. All right, moving on to problems 17 and 18. Oh, sorry, we just did 17 and 18. Moving on to problems 19 and 20 here, we're going to solve by completing the square. And there are some hints on page 509. The hints talk about the fact that these problems do not have a 1 in front, and it's important to always have a 1 in front of your problem when you complete the square. So the first thing we're going to do is divide everything by 4, because what this will do, it'll give the first term that 1 that we so desperately need to solve the problem. Of course, it does introduce a lot more fractions into the problem, but we need to have x squared plus something x to complete the square. So this turns out to be x squared plus 2x is equal to negative 3/4. Now, I'm going to space this out a little bit more because I need to complete the square. So what's going to go in that blank? Well, again, for completing the square, I'm going to take my b divided by 2 and square it. So b divided by 2 squared, that's 2 divided by 2, and squared is going to be just 1. So I'm going to add 1 to both sides. So this is going to be two numbers that multiply to make 1 and add to make 2. Well, that's going to be 1 and 1, or x plus 1 quantity squared. And negative 3/4 plus 1 is going to be a total of 1/4. We're going to take the square root of both sides, and if we take the square root of both sides, we get x plus 1, and this is going to be equal to the square root of 1/4. Whoops, yeah, come on. All right, I'm making a mistake here. There we go. If I take the square root of 1/4, the square root of 1 is 1, and the square root of 4 is 2. But don't forget your plus minus. Anytime you take the square root from now on, you should always apply plus minus to the problem. Subtract the 1 from both sides, and now I have x is equal to negative 1 plus or minus 1/2. This gives us two answers to the problem, and these two answers give us this. Negative 1 plus 1/2 is going to be negative 1/2. Negative 1 minus 1/2, or the second way, is going to be negative 3/2, or negative 1 and 1/2. These are the two answers to our problem, and by completing the square, we have figured it out. Now, in problem number 20, we're going to do the same thing. We're going to divide everything by 4. But you'll see how much more difficult the problem is. Even though our first term is now x squared, our middle term is plus 3/4 x, which is going to make things rather tricky when completing the square. Now, to spend a little less time doing this, I'm going to move this negative 5/4 to the other side. So this is going to be positive 5/4. Now I'm going to put a little blank here for what we're going to use to complete the square. Now, to complete the square is taking your middle term, 3/4, and dividing it by 2. So, little scrapwork paper up here, 3/4, 3/4 divided by 2 is the same thing as 3/4 times 1/2. Top times top, bottom times bottom, this gives me 3/8. Alright, so now I have 3/8 quantity squared that I'm going to use for this problem here, which makes 9/64. We're going to add 9/64 to both sides, which is really crazy here. Now, to get a common denominator, what you could do is you could multiply the top and bottom by 16/16. Now you can get a common denominator here of basically 80/64 plus 9/64, which gives you a total of 89/64. If you're going to add things on the calculator, make sure that you convert it into a top-heavy fraction like this, which you can use with the Math 1 Enter shortcut. Now over here, what's the difference of squares going to be? It's a little tricky to say, hey, what two numbers multiply to make 9/64 and add to make 3/4? So take the square root of this, 3/8, and you have your completed square. Make sure the plus is there because of the plus here, and there's your little 2. a little square to show that this will work. If you don't believe that this is going to be this trinomial, FOIL this out and you'll see that the end term is 9/64 and the middle term is going to be 6/8, which simplify down to 3/4. Now we take the square root of both sides to get our x plus 3/8 all by itself without the power, and then this is going to be plus or minus the square root of 89 over 64, or the square root of 89 over 64 root is going to be 8. So I move my 3/8 to the other side, so x is equal to negative 3/8 plus or minus the square root of 89 over 8, and that is my answer. Again, it'd be kind of nice to type in and see what these decimals are so you can see where this equation actually hits the ground. So you can type this in, negative 3/8 plus square root of 89 over 8, get a decimal, and check to see where it lands on your calculator. Alright, well thank you for watching the video. Again, if you have any questions, please let me know.